Hi, this is Mrs. Downey, and this is Lesson 9-4 of Algebra 2, Arithmetic Series. So our objective today is to define arithmetic series and find their sums. I started off with a little bell work here about some chairs that are lined up in an auditorium. It says the first 4 rows of chairs are set up for a meeting. The seating pattern is to continue through 20 rows. How many chairs will there be in all 20 rows? Explain your reasoning. So how many total chairs will you have at the 20th row? So when you think about this, we start with 1, 2, 3, 4. The next row has 1, 2, 3, 4, 5. Next row, the third row, 1, 2, 3, 4, 5, 6. The fourth row has 1, 2, 3, 4, 5, 6, 7. So what can you do to determine what's in the 20th row without drawing all 20 rows? So pause this video and think about it. See if you can write an equation and tell me how many chairs will be in that 20th row and how many total chairs will there be altogether. So I'm going to pause the video now, and you should too. Come back when you're ready with your answer. Okay, so in our first row, we know we have 4 chairs. And we know that we want to find out what's on the 20th row. So we're going to let our first term in this sequence be a sub 1. A sub 1 is equal to 4. Well, what's our difference? When you look at the difference in each row, it's growing by 1. So our difference is equal to 1. From row to row, we're just adding 1, plus 1, plus 1. So that's our common difference, right? So how many chairs will there be in the 20th row? Well, for that, because this is a mathematical or arithmetic sequence, we know that we can use the explicit formula. So to find the 20th row and then to get the total, we have to add all the rows together. Okay, but first we're going to find the 20th row. So we're going to use an arithmetic sequence. All right, so we're going to use the explicit formula, the explicit formula for arithmetic sequence. So we're going to write that. A sub n is equal to a sub 1 plus n minus 1 times d. And we know that our difference is just equal to 1. And we know our first term, a sub 1, is equal to 4. So let's substitute. And we're looking for the 20th term. So a sub 20, our 20th term, is equal to 4, our first term, plus 20 minus 1 times our difference, which our difference is 1. So 20 minus 1 is 19. So we have 4 plus 19 times 1, which is just 4 plus 19, which is just 23. So in that 20th row, we have 23 chairs. So there's the first part of our mystery. They want to know how many chairs total now. Without drawing a picture, we know that it's going to start with 4 and it's going to increase by 1 up to the 20th row. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, all the way to that 20th row that has 23 chairs. So you have to sum all these numbers. And when you do that, you're going to find that you get. So the way I like to do this is just add every few as I go down. So I've summed portions of these up all the way down. And now we're going to sum up those in the next column. Okay, so once you add all those up, you've got 39, 126, and 105. That's 270 total chairs. So that's our answer. So our lesson today, we're going to start with some concepts. So it says just as you found formulas for terms of sequences, you're also going to find formulas for the sums of the terms of the sequences. Okay, so our essential understanding says when you know two terms and the number of terms in a finite arithmetic sequence, you can find the sum of the terms. So what's it say? When you know two terms and the number of terms in a finite arithmetic sequence, you can find the sum of them. So let's see what we can determine here. So first, before we move on, we have to understand what is a finite series and an infinite series. Okay? So we've already talked about what a series is. A series is just an indicated sum of terms of a sequence. It's the indicated sum of the terms of a sequence. That's a series. Okay? Now, a finite series, just like a finite sequence, has a first term and a last term. So we know, so look at this right here. A finite sequence, it has a beginning and an end. So we know exactly how many terms are in it. We've got 6, 9, 12, 15, 18. It has 1, 2, 3, 4, 5 terms. It has a beginning term and an ending term. That's finite. Now it becomes infinite when it has, while it continues on forever and it has no end. So just like going to infinity on a number line, well, this is like an infinite sequence. It just goes on forever. So finite has a beginning and an end, and an infinite sequence has no end. Okay? So here's another example over here. Okay, so on this side, we're talking about sequences, right? So a sequence is just an order of terms. All right, and here we have 3, 7, 11, 15, and it's infinite, so it goes on forever. The finite sequence has a beginning and an end, and a specific number of terms. Okay. Now, when you look at the series, a series is the summation of these. Okay, so notice the difference. Instead of just listing the numbers like we do in a sequence, in a series, we add them. So the plus signs are the difference here. So a finite series, you have a definite sum. You've got a beginning and an end, and you know the exact number of terms, and you know exactly what that sum is going to be. So that's a finite series. Now in an infinite series, we can't say what the total sum is going to be because it goes on forever. So that's the difference between a sequence, and a series, and then a finite sequence and series, and an infinite sequence and series. Okay? So this is going to move us on to an arithmetic series definition. An arithmetic series is a series whose terms form an arithmetic sequence, as shown above. When a series has a finite number of terms, you can use the formula involving the first and last term to evaluate the sum. First and last term. There's those two terms they were talking about up here, right? When you know two terms and the number of terms in a finite arithmetic sequence, you can find the sum of the terms. So if we know the first and the last, and we know exactly how many are in it, we don't have to know the middle. We can tell you how much that sum is going to be. So maybe there's another way to work our problem that we started today. Well, there is. So think about that as we move on. So I wrote this a lot bigger for when I was teaching to the room. So here's our property, sum of a finite arithmetic series. The sum S sub n of a finite arithmetic series where our terms are a sub 1 plus a sub 2 plus a sub 3 plus all the middle all the way to the very last term, which is a sub n, is equal to this formula. And notice that this is a capital S sub n is equal to n divided by 2 times the sum of a sub 1 plus a sub n. Okay, so let me clear this. There we go. All right, so again, it's right here. Capital S sub n. So the sum of a finite arithmetic series is denoted by S sub n. So that sum is equal to n, which is your number of terms, divided by 2, times the first sum plus the second, or the last term. Okay, so that's all there is to it. So let's look at how to use this. So problem 1 says finding the sum of a finite arithmetic series. It says what is the sum of the even integers from 2 to 100? So we know there's a series here. It starts at 2 and it ends at 100. So they want to know what is that series and what is the sum of all those numbers. So it says the even integers, sum of the even integers from 2 to 100. So we know it's going to go 2, 4, 6, 8, 10, 12, all the even numbers all the way up to 100. So that's an arithmetic sequence with our first term being 2. So we can say our first term is equal to 2. And our last term, a sub n, well actually we know that because it's all the even terms, there's going to be 50 terms, and they tell you right there. The 50th term, the very last term. So a sub 50 is going to be equal to 100. So there's your first and last term. That means that our n is equal to 50. Our number of terms is equal to 50 because the last one is a sub 50, right? And we have a common difference between all of these of 2. We have to add 2 each time. So our difference is equal to 2. So we've got all of our information right there. So now we're going to plug it in our formula that we just did. So S sub n, which is S of sub 50, is n divided by 2, which is 50 divided by 2, times your first term plus your last term, 2 plus 100. So we know 2 plus 100 is 102. 50 divided by 2 is 25. So we have 25 times 102, which is equal to 2,550. So that's how you determine what the sum of that sequence is of all the even numbers from 2 to 100. And that's all there is to it. Okay, so there's a got it. But let's just move on to our workbook problem. On 9-4, let's look at problems 1 through 6. And let's work the first one together, and then you'll pause the video and work the next 5. Okay, so before we work that, just in case if you want to work this one, the got it, pause it and work it now. Okay. And when you come back, we'll go over it. So pause now if you want to work it. Okay, so now I'm going to give you the answer to the got it. And here you're going to use your summation formula there. S sub n equals n divided by 2 times your first term plus your last term, which is 1 plus 99. There's 50 terms divided by 2. So it's going to be 25 times 100, which is 2,500. So that's the got it problem. So let's look at problem 1 on our workbook. In 1 through 6, it asks you to identify each list as a series or a sequence? And is it finite or infinite? Is it a series or sequence? And is it finite or infinite? Okay, so let's look at number 1. So it says 1, and they give us 2, 6, 10, 14 with commas in between, and then the last real clue there is the ellipse. So we know because there's commas between each of these, it's a sequence. Okay, and because of the ellipse, it's infinite. Okay, let's look at number 2. Well, because it says 1 plus 4 plus 7 plus 10 plus 13. So because there's a plus in between all of these, it's a series. And because there's no ellipse, it's finite. So we can say this is a finite series. Now pause the video and do 3, 4, 5, and 6. And notice 6 does not have commas. So read number 6 like -2 plus -11 plus -20 plus -29 plus so on and so forth. Okay, so pause the video now and work those. Come back when you're ready to move on. So problem 2 states, it's a word problem, and it says using the sum of a finite arithmetic series. So now we're going to use this in a real-world situation. So it says bonus. A company pays a $10,000 bonus to salespeople at the end of their first 50 weeks if they make $10 sales in their first week, and then improve their sales numbers by 2 each week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the salesperson make in all in week 50? And then in all 50 weeks. So first we have to find what did they make in week 50. So we know it making the minimum. It says if they make 10 sales in their first week. So that would be their minimum. 10 sales in the first week, and then improve by 2 each week, so the difference would be 2. So let's see, and this goes on for 50 weeks, so we know it's a finite series of 50 terms. We know the beginning term, but we need to find the 50th term. Right? So we need to know what that last one is so we can plug that in to our series and get the sum of all 50 weeks. So first we're going to use, and here's the things I just talked about. Our first term, a sub 1 is equal to 10. We know each difference is 2. And we know this is an arithmetic sequence, so we're going to use the explicit formula to find the sales for week 50. So this is from our previous lessons. So plug in the appropriate numbers. So a sub 50, the 50th element, is equal to the first term, which is 10. 10 sales the first week, plus, and we know it's going to go on for 50 weeks, right? And we want to know what is that 50th. N equals 50. So n minus 1, 50 minus 1, times the difference, which is 2. So now it's going to be 49 times 2 plus 10, okay, which is 10 plus 98, which is 108. So we know that 50th week they're going to have 108 sales. If they start at week 1 with 10 sales and increase by 2 every week, by the 50th week they'll have 108 sales. Now that we know the difference, the first and last term, which is 10 and 108, now we can plug that into our series. So we know it's 50 terms in all, so S sub 50 is equal to 50 divided by 2 times the first term plus the last term, so 10 plus 108. So it's 25 times 118, which is 2,950. So the 50th week, they'll have 108 cells, and for the sum of all 50 weeks, the sales of all 50 weeks will be 2,950. And that's how you work these. So the salesperson made 108 sales in the 50th week and 2,950 sales in all 50 weeks. So that's how you work these. Okay, so if you look at problems 7, 8, 9, and 10, there's an error on number 11. So let's correct that error first, okay? So on number 11, change your workbook. On number 11, it shouldn't say 299. It should say -99. So on number 11, it goes one more time. Number 11 is -4 plus -9 plus -14 plus ellipse plus, and then it says 299. That's what you want to change. That's a typo. That should be -99 there, okay? Then you can get an answer. If you don't, you'll never be able to calculate that on number 11, okay? So make sure you make that change. And now work number 7 through 11. So if we look at number 7 together and work the first one together, they've started it for us. It says find the sum of each finite arithmetic series. So on number 7, they give us 1 plus 3 plus 5 plus ellipse plus 99. So we know we've got a finite series, and we know the difference each time is plus 2. So our difference equal 2. We know our first term is 1. And we know there are 50 terms, because if we're adding 2 and we go from 1 to 99, there's going to be 50 terms. Okay. So let's start. So they said find the number of terms, then find the sum. But actually, forget I just did that. We're going to calculate the number of terms, because that might be hard for some to see, and it might not always work out that way. What if we're not doing by 2's, right? So let's see formally how to do this. So we're going to find the number of terms, then find the sum. So to get the number of terms, we're going to say, well, the last term is equal to the first term plus n minus 1 times d, right? Now we're going to use that last term, which was 99, is equal to the first term, which is 1, plus n minus 1 times our difference. And all the difference in those are 2, right? So next, we're just going to do the math. So we're going to say that 99 is equal to 1 plus 2n minus 2, because I just distributed that 2 to both terms. And now 1 minus 2 is -1. So it's 2n minus 1 equals 99. Now keep solving, add 1 to each side, and we get 100 equals 2n. And divide each side by 2 to get n equals 50. There, we proved that there are 50 terms. Okay, and that's also in the workbook for you. So that's how you find the number of terms first. Now let's go find the sum. Okay, so let me use a different color now. All right, so we're going to say, use our formula that we learned today. S sub n equals n divided by 2 times the first term plus the last term. Okay, so we're going to say S sub 50, that's our last term, equals n, which is 50, number of terms, divided by 2, times the first term plus the last term, which is 1 plus 99. So that's going to be 25 times 100, which is equal to 2,500. So S sub 50, our last term, is 2,500. Okay? So, keep going in class so you get all of this instruction. Work 8, 9, 10, and 11 at home. And let's keep going. So, our next problem is all about summation still. So what we need to do is know some signs and a little bit more terminology. So it says we can use the Greek capital letter sigma, which looks like a sideways M here, to indicate sum. So when you use it, you use limits to indicate how many terms you're going to add. Limits are the least and the greatest values of n in the series. You write the limits below and above sigma to indicate the first and last terms of the series. So the upper limit, the series ends with n. Oh, first, let's go to the left here. For example, you can write the series 3 squared plus 4 squared plus 5 squared plus ellipse plus 108 squared. So there's a finite series, and we can write that as sigma and look at the top. So we've got 108, that's the number, 108, and then our first term is 3. So we're going to say sum for n equals 3 to 108. So the beginning goes on the bottom, the last term goes on the top. So it's right here. And then for each one of those n's, we're going to do n squared. And see, that was 3 squared, 4 squared, 5 squared, all the way to 108 squared. So begin with 3, end with 108, and we're doing n squared. So sigma means sum from n equal 3 to 108, n squared. So that's how you do these. All right. So for an infinite series, summation notation shows the infinity sign as the upper limit. For an infinite series, we use the infinity sign for the upper limit. Okay, so if it was an infinite series, you wouldn't have that finite 108 there. You would have the infinity sign. Okay. So to find the number of terms in a series written in sigma form, subtract the lower limit from the upper limit and add 1. So the number of terms in the series above, in this one right here where I'm moving my mouse, would be 108 minus 3 plus 1. So it'd be 108 minus 3, which is 105 plus 1. So it'd be 106 terms in that series. So a minute ago when I just gave you the number of terms, I've done this, but now you can do it. All right, so that's a quick way to tell how many things in a series. All right, now let's move on. So writing in a series in summation notation. For multiple choice question, it says what is the summation notation for the series, and they give us 7 plus 11 plus 15 plus ellipse plus 203 plus 207. So each time it looks like they're adding what? So when you look at these, they give us a lot of different things here. They give us sum from 1 to 51, 4 times n plus 3. Well, does that look right? So is this first term, n equal 1, 4 times 1 plus 3? Well, that would give us 7. How about the second one? 4 times 1 plus 3 gives us 7. And then 7 times 1. Well, what about the next series? Test that. So now we're going to have 2. So now when n is equal to 2, we're going to say 4 times 2 plus 3. So 8 plus 3 would be 11. That's correct. Same thing here, 4n plus 3, that would give us, now what about this one here? So when n is equal to 2, you're going to have 7 times 2, which is 14. So that puts both of these out. That doesn't hold true by the time you get to your second term. So now, what's different between these? You've got a total number of 51 and a total number of 50. So remember what they told us. How many terms are there? Well, we're going to have to do some math. Okay, so I showed you a little bit how to grind things out, and now let's look at it with our formulas. So we know the sequence is arithmetic because it has a beginning and an end, and the first term is a equals 7, and the common difference between all of these is 4. So we're going to use our explicit formula for an arithmetic sequence because that's what we're dealing with. So a sub n equals the first term plus n minus 1 times the difference. So now fill in your first term and your difference and solve for n. So what do we get? We end up with our series is equal to 4n plus 3, which we already figured that by just playing with it. But there's the mathematical way to determine it's one of these two. Now we have to decide how many terms does it have, 50 or 51. So now we're going to use our explicit formula again to find the value of n for the 207, the term 207. So we know that the formula a sub n equals 4n plus 3. So now we know that last term, 207, is equal to 4n plus 3. Now we're just going to solve for n. So subtract 3 from each side and then divide each side by 4, and we get the number of terms for n. N is equal to 51. So we have 51 terms. That means that A is our correct answer. Okay? So our upper limit is 51, and that's how you write it. Our correct answer is A. Okay? So now I would like for everybody to keep moving on, but your problem set for these tonight, oops, let me find it, is problem 3. I want you to work skip 12, and you're going to do 13, 14, and 15, like this problem. 13, 14, and 15. And 13, they've basically done it for you, and you're going to figure out the number of terms, which they already gave you. If you look in the second column, it says n equal 54. So you're going to use that pattern of how they solved this problem to do the next two, 14 and 15. Okay? Then you'll write your summation. All right, and then that gets us to our last problem, number 4. Finding the sum of a series. So what is the sum of the series written in summation notation? So here we go. And this is really preparing us for calculus and pre-calc. So the summation from 1 to 70 for 5n plus 3. Well, what's that going to equal? So again, since it's a linear function of n, the series is arithmetic. So we're going to say our first term is 5, right, because we're going to start with 1. So our very first term would be 5 times 1 plus 3, which is equal to 8. So our very first term would be 8. Our next term, you let n equal 2. So it would be 5 times 2 plus 3, which would be 13. The next term, n equals 3. So 5 times 3 plus 3, or 18. Okay, and you do that for all of these up to the 70th term. So, from 1 to 70, 5n plus 3. So we have our first term, and we know our 70th term. What do? Just plug in 70 for n. So 5 times 70 plus 3, which is going to be 353. So we've got our first term and our last term. Now, what are we going to do with those? Plug it into our summation series. So, the sum of all 50 terms, all 70 terms, we have 70 terms right there, the upper limit, S sub 70 is equal to n, which is 70 divided by 2, times the first term plus the last term. So it's going to be 8 plus 353. So add those together, multiply by 35, and you're going to get 12,635. And that's how you work these. This is easier than all of it, right? And you'll work through. Hold on. Not 13, let's see. You'll do number 16 with this. And it's a word problem, so you'll work through all of those using this technique. Now let's look at the second problem. We have, let's do the summation from n equal 1 to 7, so there's 7 terms, and it's going to be n minus 1 squared. So when you look at this, it's not arithmetic. However, you can evaluate it just by adding up your terms. So when you look at this, we know we have 7 terms, so this is going to be easy enough. So for the first term, n's equal to 1, so 1 minus 1 squared. So our first term is 0. The second term, n is equal to 2. 2 minus 1 squared, which is 1 squared. Our third term, 3 minus 1, which is 2 squared, which is 4. Our fourth term, which would be 4 minus 1 squared, which is 3 squared, 9. Our fifth term, 5 minus 1 squared, which is 4 squared, which is 16. Our sixth term is 6 minus 1 squared, which is 5 squared, 25. And our seventh term would be 7 minus 1 squared, which is 6 squared, 36. So there we have 0, 1, 4, 9, 16, 25, 36. 1, 2, 3, 4, 5, 6, 7 terms. There they all are. So when you add all of these up, it's in the second row, you get 91. Okay? So the last thing you'll work is problem 16. And actually 17's good too. So yeah, do 16 and 17 at home, and then that's everything, guys. And you'll turn this in tomorrow at the beginning of the day. Okay? Thank you very much, and this concludes our video for 9-4.